All right, problem set 1 here, and what I'm assuming is that everybody has printed out the problem sets and you've tried all the problems. We have 6 problems in problem set 1. So before you proceed with the clip here, because I'm going to go over the answers and how to solve each of the problems, I think it's real important that you try these problems first. These are pretty straightforward, pretty much, and again, if you've had some time value of money experience, these are hopefully quick review problems. For those of you new to time value of money, these might take a little bit more time, but we can solve these. Before we begin any problem, remember the 2 golden rules of the calculator. Number 1, make sure your calculator is set on 1 payment per year. Okay, and number 2, make sure it's set on end mode as opposed to begin mode. So we want the calculator on end mode, and we want it set on 1 payment per year. And you might go ahead and clear your calculator registers to start out with a fresh time value of money menu. Now what I do is I read each problem, I'm going to identify what type of problem it is before we go on, and then I'll set up the time value of money menu for you. And then you can go ahead and put it into your calculator. You might also write these, the answers down on your page, just in case you want to go back and double check later. But the excuse me, first problem. Albert deposits $4,500 in a savings account paying 8% per annum interest. How much will he have if he leaves this money on deposit for 22 years? So what we want to know is how much money will be at some future point in 22 years. So what we have is definitely a future value problem. So I'm gonna write FV over here. And our 2 options under future value would be future value of a lump sum or future value of an annuity. Well, the problem just talks about 4,500 into an account, not periodically, not monthly or annual. So this is the future value of a lump sum problem, or compounding. And to set it up on the calculator, because I know that I'm solving for a future value, I'm going to go ahead and put a box in the future value. Whatever I'm solving for, I put a box in that in that register, and then you simply go and plug in what you know. And if you know 3 things, you can always solve for the 4th. But I know what n is. I know n is 22. I know the interest rate is 8%, so I'm going to enter it as 8. And I always double check to make sure my units are the same between n and I. N is in years, I is in years. I'm okay, I'm good to go. So they're in the same time periods. Present value, what's going to be present value? That's the 4,500. We're going to invest 4,500. And there's no payment in this problem, is there? So make sure payment is empty, or go ahead and put 0 in it, just to be sure. And then compute or calculate future value, and you should get, it's going to come out to be a negative $24,464, and I think that's about 43 cents if I can read my writing correctly. Hopefully that's a 9. I think it's a 4. But that's $24,464.43. And we should be getting the same number, to the penny, if I'm reading my notes correctly. Okay, number 2. Jane has inherited a tract of land. She believes that she can sell the land in 8 years for a price of $50,000. Assuming that Jane's required rate of return is 9% per year per annum, how much is the property worth? How much is the property worth in today's dollars? So that's the hint right here that we're solving a present value problem. And then under present value, we got is it the present value of a lump sum or the present value of an annuity? Well, once again, it's a lump sum because we don't have periodic payments. So I'm going to go ahead and set up my calculator time value of money. While I'm doing this, you might want to clear your time value of money registers to make sure you're starting fresh. And I'm going to go ahead and put a box in present value, right, because I know I'm solving for a present value. And then simply fill in what you know. And I got to fill in three things, and hopefully I know three things. I know that n is 8, so I'm going to put n into 8, or 8 into n. Sorry, a little dyslexic there. My interest rate is 9. I'm going to double check to make sure my interest rate and my n are in the same time periods, and they're both in years, so that's good to go. Going to make sure PMT is empty, or put 0 in it just to be safe. And I know my future value is 50,000. So go ahead and compute present value, and you should get, it's going to be negative $25,093.31. Trying to write as neat as possible, as I possibly can. So if Jane maybe buys the property for $25,093.31, and she does sell it in 8 years for $50,000, she'll make exactly a 9% return on that investment. Okay, number 3. Malcolm wishes to save for a down payment on a house. He will need $10,000 in 5 years. How much must he save each year if he makes a deposit at the end of every year and he receives 7% per annum on his money? So what kind of problem is this? A mortgage payment, present value, future value? Well, this was the sinking fund, right? So I'm going to write next to this sinking fund, not stinking fund, sinking fund, because I'm trying to figure out how much I have to save each year to accumulate $10,000 in 5 years. So while I'm doing this, make sure you clear out your calculator registers and then think about what we're going to be solving for here. Is it a PV, a PMT, or a future value? Well, sinking fund, what we're doing is we know the future value and we're solving for PMT, the payment we have to make every year to accumulate some future value. So I'm going to put the box in payment, and then as usual fill in what I know. I know n is 5. I know the interest rate in this problem is 7% given to us. I'm going to double check and make sure the n and the I are in the same units and they're both in years. So that's good. I can continue on here. What's present value? Well, nothing. Okay, make sure present value is empty. There's no present value in this problem. Put 0 in just to be safe if you want. And the future value is 10,000. So how much do we have to save every year for 5 years, making payments at the end of each year, to accumulate $10,000 in an account yielding 7% per year? Well, that's $1,738 and looks like 91 cents. So $1,738.91. And it comes out to a negative, and the reason I entered 10,000 into the future value as a positive is because that's how much money we're going to have at the end of 5 years. And what I like to try to do in these problems is try to keep the signs consistent with the problem and the cash flows of the problem. So I'm going to withdraw. I'm going to need $10,000 in 5 years. What I'm going to do is I'm going to make investments of $1,738.91 each year, and I entered that that's a negative because that's money going out of my pocket. So if I invest $1,738.91 each year, I'll have to spend or to make my down payment of $10,000. That's money coming into my pocket. Okay, let's scroll up a little bit and look at number 4. I'll leave number 3 up there just in case you're writing stuff down. But number 4, okay, again, you should be thinking, what type of problem is this? What of the 6 time value of money options is appropriate for this problem? And the problem is Sarah has an opportunity to buy a lake house from her friend for $60,000. She will make a 25% down payment, and her friend will finance the balance with a mortgage calling for annual payments over 20 years at 8.5% per annum interest, per year interest. How much are Sarah's payments? Okay, so that's a giveaway at the end there. We're talking about mortgage payments. So this is a mortgage payment or a mortgage constant problem. And how much is the mortgage in this problem? Now, be very careful about this because this is a common mistake. The problem is giving us the sales price of the house, not the mortgage amount. So Sarah isn't financing 100% or $60,000. She's financing how much? If she has to put in 25%, well, she's financing 75% of $60,000, and 75% of $60,000 is what? That's $45,000. So the mortgage amount is $45,000, and Sarah has to come up with the balance, or $15,000 as the down payment, the 25% equity down payment. Okay, but let's set up our calculator. Again, while I'm doing this, you can be clearing your calculator registers. And as always, I'm assuming everybody's calculator is set on 1 payment per year, and we're still in end mode, END. Okay, since it's a mortgage payment problem, I'm going to go ahead quickly and put a box into payment, because that's what I'm going to be solving for. And then I just simply fill in what I know. Excuse me. N is 20, and I'm going to enter 20. It's annual payments. Now, this isn't a typical mortgage, is it? Typically, our mortgages are monthly payments. So we'd have to put in the number of total monthly payments as N if it was a monthly payment mortgage. But this, to get us started, you know, you don't see a lot of these necessarily, but this is annual payment mortgage. So there's going to be 20 payments. So N is 20. The interest rate is 8.5%. So I enter 8.5 into my calculator. I double check to make sure my N and I are in the same units, years. They're both in years, so I'm good to go with that. And what's my PV in this case? Okay, my PV, yep, don't say 60. Please do not say 60. That's the sales price, but we're just making the mortgage calculation, and we're borrowing 45,000. Now I'm going to leave that as a positive because I'm looking at this from Sarah's perspective, that she's going to get $45,000 to buy the house, and that's money into her pocket essentially to buy the house, and then she's going to be making monthly, not monthly, I'm sorry, annual payments, and that's money flowing out of her pocket. So whatever I compute is going to be a negative. Before I hit compute though, I want to make sure my future value is empty, or put 0 in it just to be safe, and then compute payment. What do you get? Okay, yeah, it should be a negative number, and it's negative $4,755.19. Let's take it to the penny because the lenders are interested in their pennies. Okay, so that's $4,755.19. That would be Sarah's annual mortgage payment over 20 years, the same payment for each of 20 years. Okay, number five, Tom will open an IRA savings account at the end of this year. And that's a great advice for anybody. So if you haven't looked into IRAs, individual retirement accounts, either traditional IRAs or Roth IRAs, because of the power of compounding, the sooner you open this up, the better. Because if you start saving early and you have lots of years to save, that the money that you're going to accumulate, the interest or the money that you accumulate in that account is going to start compounding, and you'll start to make compound interest. So the sooner you start these things, the better. And as soon as you have some earned income, you can open up an IRA, individual retirement account. He will save $2,000 per year for 40 years in an account paying 9% per annum interest. How much will Tom have in the account when he retires in 40 years? So we want to know some future value, right? That's what we're going to solve for. And what type of future value problem is this? Well, this sounds like a future value of an annuity, because we're going to be putting in an equal amount, $2,000 per year for 40 years. So that's exactly what an annuity is, a good example of an annuity. And once again, while I'm setting up our time value of money menu, you could go ahead and clear your calculator registers. And we just said we're solving for future value, so I'm going to go ahead and put a box in future value and then fill in what I know. Okay, n is going to be 40. I is 9%. And n and I are in the same time period, the same units, years. So that's good. Okay. Present value is nothing, empty. We're starting out with 0. But we're going to make payments at the end of each year of $2,000 per year. Okay. And then go ahead and compute future value. What do you get? Well, actually, I'm going to make a quick switch here. I'm going to make 2,000 a negative, because that's money going out of our pocket, and I'm trying to be consistent with what I said in the previous problems. So let's make payment a negative $2,000. So what comes out is a positive $675,764.89. So if Tom starts his IRA account, puts away $2,000 per year for 40 years, and this account does make 9% per year interest, Tom will have at the end of 40 years $675,764.89 in that account. My question to you is, how much of that is interest and compound interest? Well, we could do a quick calculation here, and if you take 40 times 2,000, okay, 2,000 times 40 is the amount of money Tom actually put in that account, or Tom put in 80,000. So only 80,000 of the $675,764.89 is principal, or money that Tom actually put into that account. So the balance or $595,764.89 is either interest or compound interest, interest on interest. Okay? Well, just a little aside there. Well, let's finish up here with 6, and then we'll go back to the notes and later move on to more problem sets, more difficult problem sets. The final problem, though. Lucille is considering investing in a parking lot. The tenant is the government, which pays an annual rental of $2,000. In 15 years, the lot will become the property of the government and has no value. How much should Lucille pay for the lot if she requires 11% per annum return on her investments? So what type of problem is this? Well, we have $2,000 per year, and we have no value in the future. Okay, so at the end of 15 years, the property is worth nothing. And we want to know what to pay for the property today to generate or achieve 11% per year rate of return. Well, this sounds like a present value problem. So I'm gonna write over here PV, and it's not a present value of a lump sum, is it? Because we have 2,000 a year for 15 years. So that's the present value of an annuity. So now that I know what I'm dealing with here, I'm going to set up my calculator. You might go ahead and clear your calculator registers. And I'll put a box in what? I'm going to box present value. That's what I'm going to solve for. Nice to have some room here. And then fill in what you know. Okay, I know n is 15. I know I is 11. I also know, or going to double check, that N and I are in the same units and years, so I'm good to go there. My payment, okay, my payment is $2,000. I'm going to enter that as a positive because from Lucille's perspective, she'll be getting $2,000 a year, in her pocket. That's a cash flow coming in, positive cash flow. Future value, make sure is empty or put 0 in, because the parking lot will become the property of the government and have no value at the end of 15 years, so there's no future value. And then go ahead and solve for PV. What do you get? Okay, it's going to be a negative $14,381.74. So if Lucille buys this property, or a cash flow going out of her pocket, if she spends $14,381.74 and does in fact receive $2,000 a year per year for 15 years, she'll achieve exactly 11% return, rate of return. Okay. All right. Well, signing off. We'll see you in the notes in the next problem sets.